my dear friends, welcome to IMS Academy. I hope you are doing good, and we are back with yet another session of the foundation series that we have been doing since past 1 week. And today, as I said, that we will be starting with a new topic. So today's topic of discussion is one of the most important chapters, whether you are preparing for GATE or any other examinations, or you are preparing for your semester examinations. The topic name is SFD and BMD, shear force diagram and bending moment diagram. So till yesterday we have been completing, we have been into a stress transformation topic, and I highly recommend you that in case if you have not gone through the topic, please go through it. Most of your concepts would be clear and you will face no problem as to understand the topic in its advanced stages, right. So my dear friends, before we go on to the topic, this is our Telegram channel. You can consider it joining, and once you join it, you will never miss any important notification. Along with that, you will be a part of daily quizzes which the faculties on regular basis keeps on posting. So PSU and other government job notifications, any daily quizzes, many more, right. My dear friends, you can consider joining our GATE 25 live online program, where you will be having an access to 800 plus hours of live classes. Then you will be exposed to theory book, exercise book, which contains 4,000 plus questions. Along with that, you will have the most important thing, the GATE question bank of 34 plus years you will be having. Yes, 34 plus years GATE question bank, and let me tell you that you will be getting 2 books, one with the core which deals with your core subjects, and another which deals with the engineering mathematics aptitude of all the branches. And one-to-one session is one of the USPs of IMS GATE Academy, where a mentor interacts with you personally in 12 such online sessions, where you can be asking your any kind of doubt, the general doubts regarding your test series, your preparation, your how the classes are going, in case any doubt is there. So many more things you can discuss with your mentor. And apart from that, my dear friends, nothing is complete without the test series. So you will be getting 130 plus online tests with video solutions of important questions and much more. In much more, what is much more? Chapter tests, subject tests of all the chapters. So my dear friends, you will be exposed to so many things if you join our GATE 25-26 online program, right. So after that, let us move towards our today's topic, and our today's topic is of course SFD BMD. But what is this, my dear friends? This is a beam. This is a beam. What is a beam? A beam is a structural element on which loads which are perpendicular to its longitudinal axis are applied. So a beam is an element. A beam is a structural 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 element. So this is the beam. I hope you are able to see. Now what is the longitudinal axis? Axis along the length. Axis along the length. Axis along the length is the longitudinal axis. Axis along the length is the longitudinal axis, and loads which are perpendicular to the longitudinal axis, it will be applied. So loads which are perpendicular to the longitudinal axis, that is being applied, so that is called the beam. My dear friends, why this is so much important? It is important because it forms the base of your buildings, bridges, then used in transportation, cars, buses, so many things, my dear friends. So beams are very, very crucial in our day-to-day life. What is the main purpose? The main purpose that it will resist your external loads. It will resist your external loads. There will be different types of beams, my dear friends. So what are beams? Beams are long straight members which are subjected to loads perpendicular to longitudinal axis, and they are classified according to the way they are supported. So for example, your beam can be simply supported, your beam can be cantilevered, or it can be overhanging. Now what are they? I'll try to show you. So my dear friends, beams are classified as per the way they are supported. So you can see that in a SSB, that is the simply supported beam, one end is your hinge joint or pin joint, other is your roller joint. In your cantilever beam, one end is completely fixed and other end is free. Another is your overhanging beam, in which either one end or both the ends extends after the support. Some portion is overhanging, so it is called overhanging beam. And regarding beams, it can be asked that which is your statically determinate system, statically indeterminate system. This year also a question came that which of the following is statically determinate, indeterminate. So you have to solve that question based on that how many unknowns are there and how many of your static equilibrium equations are there. Static equilibrium, 3 equations are there. So if the number of unknowns to be determined is more than the equilibrium equations, it is indeterminate. If it is less or equal, it is determinate. Fine. So right now I am not going into statical indeterminacy of the beam, but so the thing is, my dear friends, that when the beams is subjected to external loads, definitely it is going to resist, and for it to be in equilibrium, it will develop internal shear forces and bending moments, my dear friends. Yes, if it is resisting your external loads, or as a response to your external loads, the beams are going to develop what? Internal shear and internal moments. Internal shear and internal moments, which varies across the beam. Now for example, if I show you over here, the moment might be less, over here the moment might be more, over here the moment might be maximum. Similarly, at this portion the shear force might be minimum, at this portion shear force might be maximum. That means the shear force which it develops, it keeps on varying across the length of the beam. And when something is varying and your purpose is eventually to design something, so isn't it your duty to know that which part is subjected to maximum shear and which part is subjected to maximum moment? For example, suppose that this portion of the beam is subjected to maximum shear, so I might consider giving it a reinforcement so that it doesn't fail, right? So how we are going to get it? How we are going to know, or how will we know that which part is subjected to maximum shear, which part is subjected to maximum moment, and so on and on? So for that purpose, we have to construct SFD and BMD, that is the shear force diagram and bending moment diagram, right. So, the purpose is clear, the purpose is clear. Not only that, my dear friends, this is one advantage of drawing the SFD BMD. Second thing is that once you know the bending moment, later on you will get to know that due to bending moment, bending stresses comes into picture. So, if the moment is clear, so you will be able to find the bending stresses, which is normal in nature. So, that chapter also SFD BMD helps us to calculate the bending stresses, right. So, my dear friends, what is shear force? What is shear force? So, shear force, before knowing, means before we can draw the SFD, it is very important to know that what is shear force. So, it is the algebraic, for example, at a section, if I have to draw the shear force, it is the algebraic sum of all the transverse loads acting on an isolated segment to satisfy the equilibrium conditions. So, I'll tell you that how to calculate the shear force. For example, at a section we want to see that what is the shear force. So, you have to simply see that what are the transverse loads acting on the beam, and you simply take the algebraic sum. Algebraic sum means you can consider one direction to be positive, another to be opposite will be negative. For example, plus y axis we are considering to be positive, negative y axis negative. So, plus and minus accordingly we will find out. What is bending moment? Algebraic sum of all the moments acting on the isolated segment to satisfy the equilibrium condition. So, I will tell you how to calculate all these things, I will tell you, do not worry. And what is SFD BMD? SFD is the diagram which tells you about the variation of shear force along the length of the beam, that how the shear force is varying. And what is BMD? It is the diagram which tells the variation of bending moment across the length of the beam, that is across the length I will be able to say that how the bending moment is varying. And you can also see, if once we draw the SFD BMD, you will be able to analyze very carefully, very neatly, very easily that okay, where the shear force is maximum, in which part it is positive, in which part it is negative, in which part the shear force is trying to rotate the element clockwise or anti-clockwise, and many more things we can find out. Okay. Now, my dear friends, before we proceed on for drawing the SFD BMD, it is very important to know the sign convention which is used in beams. And once the sign convention is fixed in your mind, you will have no problem drawing the SFD BMD. Okay. So, my dear friends, you will be facing distributed loads also. So, if the distributed load is upward, I will be considering it as positive. If it is downward, I will be considering it as negative. Now, coming to the shear, this is the shear part. This is the shear part. If your shear is trying to rotate the element clockwise, this is very important. If this is clear, you will have no problem. If your shear is trying to rotate the element clockwise, then we will consider it as positive shear. So, at a section you go and then you see that whether it is trying to rotate the element clockwise or anti-clockwise. If it is clockwise, it is positive shear. If it is anti-clockwise rotation, it is negative shear. When it comes to bending moment, your moment, whether it is trying to rotate the beam in this way such that the upper fibers are subjected to compression, then it is the case of positive bending moment, that is the smiley sign you can you can keep in mind. And if your bending moment is trying to create a hog effect on the beam, this is the sagging part and this is the hogging effect. So, this is the hogging effect of the beam such that you can memorize it by the sad smiley part, sad part. So, if it is trying to create an effect in this way, then it is called negative bending moment. This is called the sagging effect, and this is called the hogging effect. So clear SFD, BMD, SFD, when can we say that the shear force is positive? When it is trying to create a clockwise rotation. Shear force when it is trying to create a clockwise rotation on an element at a section, then it is called as positive. And when the shear force is trying to create anti-clockwise rotation, then I will say it is negative. Okay. So is the sign convention clear? I hope the sign convention is clear. Now my dear friends, I have written few steps for you so as to construct the SFD and BMD. So what is the first step? The first step is I am going to determine all the forces which are acting on the beam. I am going to determine all the forces which is acting on the beam. For example, I need to draw the SFD, I need to draw the free body diagram of the beam. Okay. Secondly, I have to consider a reference system. I have to specify the origin. With respect to that only I will be taking the distance. So left part of the beam I will be considering as my reference point, and from there I will be taking the distance. That means all the distances I will be mostly measuring from the left. See my dear friends, convention is something which you can also take, but we are going to follow that convention which is widely practiced. That's it. At any section X, I will be taking some section, and then I will be analyzing that within that section what are the forces which is there, what are the moments which is there, and as per that only I will be writing the SFD equation and I will be writing the BMD equation. And my dear friends, one more thing, between discontinuities only we have to analyze a segment. Now what is meant by discontinuity? I will try to explain you. For example, you are facing this one. For example, this is a beam. I am not drawing the support. Now imagine that this is one reaction, here is one loading, and here is one loading. So if I have to, let me name it also. For example, this is your point A, this is your point B, and this is your point C. So I will be writing equations of SFD BMD first for the AB part. Separately I have to analyze this AB part, and separately I have to analyze then the BC part. Are you getting or not? That means between discontinuities I will be writing the equations. Discontinuity means at A there is one point load and at B there is another point load. So I will not be writing all together, I will be considering only first AB and then BC, right? Because discontinuities, in between discontinuities we write the equation. Okay, so this is the thing. I will repeat it again before I go on to solve the first example. The steps are, first I have to remove the supports, and then I have to see what are the reaction forces, what are the other forces which are being there on the beam. Secondly, between discontinuities I will be analyzing it, I will be taking a section, I will be writing equations of SFD BMD, and then reference system I will be taking it from the left. X is from the left, from the right also you can take, that is your wish, but I will be considering it for left. And finally I will be writing equations for SFD and BMD. So today we are going to see how we are going to use equations. I have to write equations for SFD and BMD. Using equations only we have to draw SFD BMD. Is it clear or not? And tomorrow we will be seeing how with the help of graph we are drawing SFD BMD. So today is the analytical part, the equation, how we are using equations. Okay. So no matter how much I shout over here, you will not be able to understand until and unless I take a question. So my dear friends, this is the first example. We will be starting with basics only. This is the first examples that we will be taking for understanding the concept of SFD and BMD. Fine. So let us draw some diagrams. Okay. So I told you that first job is to draw the free body diagram. So this is P. Now tell me, my dear friends, when you see when you apply this force over here, one vertical force will come into picture, right? Okay, and this P is also trying to create a moment. That means moment is clearly, you can imagine that something is there, some rake is there. If you apply force, so definitely it will try to create a moment. So when moment is there, so it will also resist, so moment will also develop, So P into L is the value of the moment that will develop. Okay. So first, upward reaction force will develop. If I remove the support, upward reaction, and since this is the external load P is trying to create a clockwise moment, so the resistance will be anti-clockwise moment. Let's say this is M, let's say this is P, and let's say this is P. So I have shown all the forces which are acting on the beam, and also what is the distance? The distance of this is L. 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 Okay. Right? Is it clear? Okay. So what is the thing? The thing is that I will be considering one section like this. I will be considering one section, let's say this is the section X and X dash, which is at a distance of X, from the left hand. And then what I will write? I will be writing equations. So at the section, so let me take another pen, else it is all greenish. So at the section X dash at distance X from the left hand, at distance X from the left side, we have already discussed. So if I have to write the shear force equation at X dash, so what is shear force? Now you see, now you read that definition. Now you read this definition, that what is shear force? Shear force is the sum of all the transverse loads, including the reaction also included, acting on an isolated segment to satisfy the equilibrium conditions. Now you will say, sir, where is the isolated segment? So this segment which I am considering, okay, this segment which I am considering, so this is the first question, so I am showing you the isolated segment. So this segment that we are considering, this is your isolated segment. So this is your P, this is your moment, and at section XX, at section XX dash, definitely there will be some shear force Sx dash. So this only I am trying to find out. This only I am trying to find out the value of the shear force at XX dash. This is only I am trying to find out. So two things you can find out directly. You can write out what is XX dash directly. You can write as this way, or if you want, you can apply summation Fy equal to 0. That means either you can write this equation equilibrium in y direction is equal to 0. So this is only I am doing. This is what I am doing. All the transverse forces acting in the transverse direction, that is only I am trying to do. But directly you can write like this also, Sx dash is what? So what are the left transverse forces are there, you can write. So what are the transverse forces that you can see in this segment? Now every time I am not going to draw the isolated segment. From here only we can see that if we take Xx dash over here, so left hand side of this, what are the vertical force? So only one vertical force I can see, only one transverse force I can see, P, and let's say that above the line, above one reference line, I will be taking all the forces as positive, below the reference line I will be taking negative. So only one P is there, so let me write P, done. No more transverse forces are there. No more transverse forces are there, done. Now see, whether you take the section over here across the length of the beam, it will be P only. The equation will not change. The equation will not change. Are you getting or not? The equations will not change. The equations will not change. It is only P. So can I draw the SFD? Can I draw the SFD? I want to draw it over here only, so let me erase this and let me draw it here itself. Let me draw it here itself. Now see, at the left hand side there is one point load P which is acting in the vertical direction positive. So you draw P in this way, and at any section the shear force is P only. So this is P, and this after any section it is P. So it will go like this, 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 and once you reach the end, there is a point load over here. Once I reach the end, there is one point load over here which is acting in the downward direction. So from here you just put it downwards. From here just put it downwards. So this is my positive shear. This is my SFD. This is my SFD. This is my SFD. Is it clear? So once again I am saying, this isolated segment I considered, that is this one, and left hand side you see what are the transverse forces. So I can see only one transverse forces was there, P, positive upward direction, so I draw in this way, and after that at any section it is P only, so P, and finally when I go at the end, one downward acting force was there, so I again bring it down. So that means this is all about this. Now what does a very important thing, my dear friends, what does, I have written here positive, what does positive shear means over here? What does positive shear means? The positive shear means that at any section the shear force is trying to create a clockwise movement on the beam. I repeat again, what is the meaning of positive shear? The meaning of positive shear, that at any section you consider, any section, if you consider the shear force, the external loading or the shear force which is developing, shear force tries to create a rotating effect on the beam. Okay. So at any force, the shear force that is developing, it is trying to create clockwise, it is trying to bend the beam in a clockwise direction. That is the meaning of positive shear. Is it clear? So I hope it is pretty much clear. Okay. So now my dear friends, I am going to write at any distance the bending moment equation. Now what is the bending moment equation? Obviously the sum of the moments. Now at this section, what is the net moment? I am trying to find out. At this section xx, what is the net moment? This I am trying to find out. So see left hand side, what are the moments? So this P point load is trying to create a smiling effect, sagging effect. So I will take it as positive. And this moment M, which is whose value is equal to PL, it is trying to create a sad effect, hogging effect. So I will consider it as negative. So what is the net, what is the moment due to this P into x? This is at a distance x, this is at a distance of x. So what is the moment due to P into x? Okay. So P into x, y positive I have discussed, minus M, and the value of M is PL. The value of M is PL. Okay, this is the equation that I have developed. Now with the help of this only I will be trying to plot the diagram. Okay. So I will be finding moments at different points. So for example at x equal to 0, I will substitute over here. So the answer is minus PL. Then the length of the beam, across the length of the beam at x equal to L. So at x equal to L, put it over here. So it is PL minus PL, and that is equal to 0. So this is the beam that I am showing. This is the beam that I am showing. Now I know that this is the reference line. This is the reference line. This is the reference line. So I know that at x equal to 0 it is minus PL. So minus I should show it in the negative direction. And at x equal to L it is 0. This is 0. Now the question is that how to know that from this point to this 0 point, this is one point, this is minus PL, this is minus PL, and this is 0. So how to know that how we will go? I could have gone like this, I could have gone like this, I could have gone like this, or I could have gone straight away. So how do I know that what is the link that is connecting? So if you don't know how to go, while drawing graph, the only thing that can help you out is the slope. If you don't know that how to go after one point, the only thing that can save you is the slope of the diagram. So this is the line equation that I have written. So I will simply find the slope. So slope is dmmx by dx, and it is coming out to be P. So it is coming out to be P. P is a positive value. P will be given 5 kilonewton, 10 kilonewton. So it is a positive value. So from this point you have to draw positive slope, and it is constant. So slope constant means it's the equation of line. Slope if constant, that means it's the equation of line. Here also we can see it's equation of line. Second, it is a positive slope. So positive slope means what? Positive slope means, I will give you an example, that this is the point. So if it is a constant slope, I will move in a straight, this direction. Zero slope. Zero slope means I will be moving parallel to x-axis. If it's a positive slope, I have to move in this way. Why? Because if you have considered this as your x-axis, so the tan theta of it should be positive. Then only the slope is positive. Matlab, the angle that it is making with respect to x-axis should be acute. Acute means 0 to 90 degree. But angle should be always with respect to x-axis only. This thing you people are able to understand. That means tan theta. Slope is what? Tan theta. Slope is what? Tan theta. And if slope is positive, if the slope has to be positive, tan theta is positive. So tan of acute angle is only positive. And if the slope is negative, then if the slope is negative, that means I will have to move in this way. Because why? Because the angle which it makes with respect to x axis is obtuse angle. So tan of obtuse angle is negative, that means the slope is negative. I hope this thing you people are able to understand, and if this is clear, then most of your concepts will be, means you will find very no problem while drawing slopes, while drawing the diagram. So since the slope is positive, which of the three, only these three options are there, only these three options are there. So slope is positive, that means I have to move in, which direction? I have to move in this direction. So overall, the negative internal moment, bending moment is being developed in the beam, and the maximum value of the moment is PL, the minimum value is of course 0, the value also you know. So see my dear friends, once you have drawn, this is the BMD, this is the bending moment diagram, this is the bending moment diagram, this is the bending moment diagram, and this is the shear force diagram, this is the shear force diagram. So what is the benefit? Benefit is that once we know SFD and BMD, we will be very easily able to construct, we will be very easily able to find out that okay, which is the section which is subjected to maximum stress or minimum stress, and based on that only we can design it accordingly. Okay, so this was one example that I have taken, and let's take on another example. Let's take on another example. So don't worry, we will be taking sufficient examples till the time your concepts are clear. Just a minute. Okay. So let's draw the SFD, try to draw the SFD BMD for this. So first step is free body diagram. So I think this is good. Fine. So SFD means we have to remove the supports. We have to remove the supports. So at the center there is one point load, and clearly see, I am not going to waste time finding the support reactions, because by symmetry we can tell. If you want we can do also, but I will do in some tougher problems. As of now you can see that if this is P and this is at an equidistant from the ends, so at the ends P by 2 will be developed. So this is P by 2 will be developed. So this is your P and this is your P by 2 and this is your P by 2. Fine. So what I have to do? I have to draw the SFD. So I will draw a section over here. Why I have to draw a section? For example, this is A, this is B, and this is C. So I cannot consider entire beam at once, because there are discontinuity of loads. There is discontinuity of loads. So I have to consider one section, that at this section between two discontinuities I have to select a section. So I am considering one isolated segment. What is my isolated segment? Let us say this is x dash and this is at a distance of x. This distance is L by 2 and this distance is L by 2. So, the section which is there from A to XX dash, or let us say O, the section AO is my isolated segment. The section AO is my isolated segment. The section AO is my isolated segment. This thing you people are able to understand? Okay. So, at section XX, so I will not write XX, for the segment AB, what is your S at any section X? So, I told you, you have to simply see what are the transverse forces that are acting. So, only one transverse force was acting, and that was P by 2. Only one transverse force was acting, and that is P by 2. Only one transverse force was acting, that is P by 2. Now, for the segment BC, that means if you take any section over here, so if I ask you what at this section, that means at let us say D, at AD section, what is the net forces? So, for the segment B, already I have written BC, what is the XX dash? So, P by 2 and one P is there in the downward direction, so it is P by 2 minus P, so it is coming out to be minus P by 2. So, for the segment AB, your shear force is P by 2. For the segment BC, your shear force is minus P by 2. So, fine, and this is constant in nature. So, finally, if I try to draw the SFD, so for AB, let us say this is okay. So, P by 2, for the AB section it is P by 2. So, P by 2, that means first I have to start from left hand side. So, extreme left pay, there is one reaction upward which is P by 2. So, draw P by 2. Then till B point, the shear force is constant at P by 2. So, simply draw the constant thing, value. At B section there is a point load P. So, P is acting in the downward direction. So, this is P by 2. This section is P by 2, but P is more than P by 2. This is P by 2, but the point load which is acting over here P, it is more than P by 2, such that if you go P downward, so it will cross the line also. So, P you are going down, that means you are reaching at minus P by 2, and after that the segment for the entire BC, it is minus P by 2. So, it is minus P by 2 till this point, and afterwards finally there is the upward transfer shear, that is P by 2. So, simply draw it, pull it upwards. So, this is P by 2, this is minus P by 2. So, clearly you can see that it is positive shear, and clearly you can see that it is negative shear. So, that means in the first half of the beam, the shear force is trying to create a clockwise rotation effect on the beam, and in the second half of the beam, the shear force is trying to create an anti-clockwise rotation, anti-clockwise rotation. This thing you people are able to understand? Fine. Now let us try to draw the bending moment. So for AB portion at a distance x, at xx dash, at xx dash, I have to write the moment equation. So what I can write? So till xx dash, that is the AB part, only one force is there, P by 2. So what is the moment due to P by 2? P by 2 into x. And since this is trying to create a sagging effect, that is the smiling effect, I have considered it as positive. Getting or not? So what I will do? I will try to find out all the values, that is at x equal to 0, the moment is 0. At x equal to L by 2, the moment is P by 2 into L by 2, that is PL by 4. And I will stop. And also what I will do, I will try to find the slope also. I will try to find the slope also over here. So slope is P by 2, which is positive, and now you know that how the curve will go like. So let's say this is the, no, not over here, over here. Let's say this is the reference line. So I know that at x equal to 0 it is 0, at x equal to L by 2 that it is PL by 4, and slope is positive. So I know that it is going to go, like this. Okay. But this is only till first half of the beam, that means it is x equal to 0, and this is my x equal to L by 2, and this is my x equal to L. But I don't know how the later part will behave. So for that I need to write the equations again. Where should I write? Okay, here only I am writing. Okay, fine. So that means I have to consider this part. So what I will do, I will draw it again, don't worry. I will draw it again, no need to worry. So this is my P by 2, this is my P, this is your P by 2, and now I have to draw the BMD in the later part, so I have to take section over here. Now distance x you can take it from anywhere, but just for my comfortability I am taking it from the left hand side, and this distance is L by 2, and this section is xx dash. So if you try to find the moment at xx dash, so see P by 2, that is the leftmost load, is creating a sagging effect. That means the positive effect. So P by 2 into x, and this point load P is creating a hogging effect, that is a negative effect. So I will put a minus, and what is the distance from this section? It is x minus P by 2, x minus L by 2, sorry, x minus L by 2. So again I have got the equation for this part of the beam, that is if this is A, this is B, and this is C. So for the section BC I have got how the equation that is there for the bending moment. So till B point I have already found out, but since this is applicable for BC also, so I have to, matlab I can just check at point B once again. So moment at point B, that is, if I have to find at B, what value of x I will put? X equal to L by 2 I will substitute. At x equal to L by 2, because x I have taken from here, so x equal to L by 2 I will substitute. So if you substitute over here, so P into L by 2, that is PL by 4 minus P, and L by 2 if you substitute over here, so this is getting cancelled out and I am left with PL by 4. So that means it is verified that whatever PL by 4 we have found out over here, the same PL by 4 I have also found out, that is no issues. And at for C, if I have to find the moment, so I will substitute x equal to L in this equation itself. So PL by 2 minus P and L minus L by 2, so PL by 2, so that is coming out to be 0. So B point is clear, B point I know, C point is 0. So if I go back to my this diagram, so this is PL by 4, that is very clear for me that this is PL by 4, and this point I also know that it is 0, that is the extreme point is 0. But the question is that how should I go? I could have gone like this, I could have gone like this, I could have gone like a straight line, or I can go on by some curve. So the only thing that can save me from here is the slope. The only thing that can save me from here is the slope. Once again I am giving you an idea that suppose this is a point, suppose this is a point, you have three options: either you can move like this, or you can go like this, or you can come down like this. So this constant line will be the case when the slope value is 0 because then the reference line I consider xx. So with respect to x, what is the angle the line is making? 0. So tan of 0 is 0, so that means the slope is 0. If I will go up when the theta is some acute angle. So the upper line, so for example let us say theta is 45 degrees, so tan of 45 is what? 1, slope is positive. That means when the theta is, this is the when the line is making acute angle with respect to x axis, so tan of acute is positive, so slope is positive. And when it is negative, or this case, so this is the case for slope is positive, and this case, that is the third case. Why this is the case for slope is negative? Because you can see that the line is making, if this is the x axis, the line is making obtuse angle with respect to x axis, and tan of obtuse angle is negative, so slope is negative. So this is the last one is the case for slope is negative. So last one is the case for slope is negative. So I have to determine the slope, I have to find the slope, I have to find the slope. So this is my equation, mxx dash is equal to p by 2x minus px plus pl by 2, and this I can write as minus px by 2 plus PL by 2 mxx dash. So what is the slope of this? I differentiate with respect to x, minus p by 2, this is the constant term, so 0. So clearly you can see that the slope is coming out to be negative. Clearly you can see that the slope is coming out to be negative. That means from this point I have to come down. I know it's a straight line, I have to come down, straight line, I have to come down. So only one way is there. So now it is clear. Now it is clear that there is only one way that I can come, and that is this way. that is this way. So what is the slope of the first part? The slope of the first part was p by 2. So the slope over here is p by 2. What was the slope over here? Last slide you saw, the slope over here is minus p by 2. What is the maximum value of the bending moment? PL by 4, which is acting at the center. So this is your BMD, this is your BMD, and this is your SFD. This is your SFD for this figure. So from the, now you will be saying that, sir, it is taking a lot of time. For these simple figures itself, it is taking a lot of time. For this simple figure itself, it is taking a lot of time, but it was only for your understanding that how with the help of equations, step by step, we have to draw the SFD BMD diagram. So what we will do? We have to find another method, a better method by which, or I can say some quicker method by which we can save some time and get the accurate results also. So what we will do? Tomorrow we will see the graphical method of constructing the SFD BMD. Tomorrow we will be seeing a graphical method of constructing SFD and BMD, right? But don't forget equations, right? Drawing SFD BMD through with the help of equations is very, very important, and it will save you on so many occasions. It will save you on many occasions, right? So in examination, so see, the graphical method is very fast, no doubt about that. The graphical method is very fast. Tomorrow we will discuss about it. But don't forget, the equations wala pattern is very, very important, and when you have the equation, you have everything. If you have the equation to any curve or the variation, you have almost everything, because you can find the slope. Having the equation is very important, right? So today we have discussed the basics of SFD BMD, what is beams, what did we discuss from the morning, that means from the starting of the class, that what is beam, where it is important, what are the different types of beams, then due to external loading, why internal shears and how internal moments are coming into picture, what is the need to draw SFD BMD, how can we use SFD BMD to our advantage, what is the purpose of drawing SFD BMD, how it is applicable, means useful in the chapter, that is bending chapter, that due to this bending moment diagram only I will see that how bending stresses are being generated, and so many things. And finally we have seen the equation method for drawing the SFD and BMD. So tomorrow what we will do? Tomorrow we will see the graphical method of constructing SFD BMD, how it is fast, how not it is fast, and I have one more problem. So this problem you can try it in your home using the equations. You can try attempting it and draw the SFD BMD, and in chat box you can write the answer of that, what is the maximum bending moment that you are encountering over here, right? So with this I will be ending today's session, but before that, if you are liking the sessions, if you like the way we are teaching over here, so you can consider joining the Telegram group, where you will be getting all the important notifications and along with daily quizzes. And finally, if you consider joining our live online course, so these are the features that you will be getting. What are the features? 800 plus hours of classes, 34 years of GATE question bank, 12 personalized one-to-one sessions, and 130 online tests, and many more, along with so many other features as well, right? So my dear friends, only one request I have with you, that if you are finding the classes useful, do drop a like, do drop a comment, do drop like, do drop comment, share it with your friends. It may be useful for the friends who are preparing GATE on their own, and even if for the semester examination students who wants to give semesters, right. So, it is applicable for everyone who wants to develop a sound basic for the subject strength of materials, right. So, with this I will be ending today's session. Tomorrow again we will be meeting with the continuation of SFD PMD only, right. So, see you, take care, God bless, Jai Hind.